Okay, for the second part of this lecture is at the end of the lesson, students should be able to solve absolute inequalities. For the first one, which is in the form of absolute ax plus b greater than cx plus d. So both sides is a linear with absolute on one side only. So this is the first part. We will have another 3 parts on the next lecture. How to solve for absolute values inequalities. So absolute values of x less than a, by definition, it's equivalent to negative a less than x less than a. How? This is come from x less than a intersect with x more than negative a. So if it's on the number line, to find the intersection between these two sets value, so we have negative a and a, so one of it is less than a, another one is more than negative a. So where is the intersection? This is the intersection. So the answer is in between negative a and a. So by defining absolute of x less than a, it's equal to negative a less than x less than a. So this is what we call as defining the absolute inequality. Okay, so this is the area. So from negative a to a. The second one, if we have the equal sign, it is the same as the first one. The difference is only for the sign. Means that a is included for this part, the dense dot here. Okay. The next one is when absolute x is more than a. So definition. So by defining it is equivalent to x more than a or x more less than negative a. How we get for this part? So we know directly from the inequality it's positive x more positive x more than a, or it can be negative x more than a. This is by the basic definition. We have a positive x, we have a negative x. So because we want x as the subject, so how to eliminate this x? We multiply negative 1 on each side. So if we get x on the left side and negative a on the right side. But because we are multiplying with a negative number, remember the properties of inequalities, we have to change the sign. That's why we have x less than negative a. Okay, so on the number line, it will be like this. So it is the same for the more than or equal to. The difference is only we have the dense dot on the real number line. We include the value of a and negative a. There are two methods in solving absolute values inequality. The first one, the same as the equation, we have used basic definition. The second one is squaring both sides. If the both sides have absolute values, this one, if we have absolute value on both sides, not for the absolute values on one side only. Okay, this is was specific problem only. Okay. For example, we can try to solve these inequalities. Absolute of 2x plus 3 less than 5. So for this one, we have only at one side. The absolute values is on one side only. So we cannot use the squaring both sides. The same as question B. Absolute of x minus 1 less than or equal to 4. We cannot use squaring both sides. We have to apply the basic definition. Okay, how to solve for this one? So directly, if you use the basic definition, we know that this 2x plus 3 is in between positive and negative of 5. So negative 5 less than 2x plus 3 less than 5. But I prefer you to use the most basic definition, which is, yes, 2x plus 3, following the equation, it should be less than 5. So the other part, this n is actually intersection. 2x plus 3 is, we use the opposite one. So from the less one it will be more than, and then from the positive value 5 it will be negative value of 5. So you will notice here it's actually opposite of each other. The left hand side is less than 5 following the question. The right hand side is more than negative 5. So solve for each part of this. So we get 2x less than 2, so x less than 1. For the right side, 2x more than negative 8, so x is more than negative 4. So to solve these two solutions, we need to intersect these two set of number lah. So we draw the real number line. So we have negative 4 and 1, and then what we have is negative 4, x more than x less than 1, and x more than negative 4. So where is the intersection? This is the area of the intersection. So the answer is equal to, in a solution set form, is set of x such that x is in between negative 4 and 1. For question B, so absolute of x minus 1 is less than or equal to 4. So, direct basic definition, x minus 1 is in between negative and positive 4. So, but I prefer you to use the most basic definition. So, following the question, x minus 1 less than or equal to 4, opposite of the question, x minus 1 is more than negative 4. So solve for each part. So x is less than or equal to 5, and x is more than or equal to negative 3. So n, this is for less, we use n. For if question is less, so it must be n. So n is a intersection. So solve on the real number line. So one of it is x less than or equal to 5, another one is x more than or equal to negative 3. So find the intersection. So this is the area of intersection, which is in between negative 3 and 5. So the solution set is equal to a set of x such that x is in between inclusively negative 3 and 5. So that's all for this. We have the last example. To solve for 4x plus 1 more than 2x minus 5. Absolute of 4x plus 5 more than 2x minus 5. So it is more than. So what is the basic definition? It will be x more than a or x less than negative a. So it will be 4x plus 1 more than 2x minus 5, or 4x plus 1 less than. So we have more than following the question and less than opposite the question with negative sign. So solve for each of these. So for the left hand side we have 2x more than negative 6, so x should be more than negative 3, and the other side will be 4x plus 1 less than negative 2 plus 5, so it will be 6x less than 4, so x less than 2 over 3. So because the definition of more than, we have or, so to accept this answer, so draw on the number line. So x more than negative 3 and x less than 2 over 3. So draw on the number line. So the union of these two sets is actually everything. So we want to get the union. So everything on the real number line is the answer for these inequalities. So the solution set is actually any value on the real number line. So it's actually from negative infinity to infinity. So we can represent as real number line as the answer. Any element on real number line. Okay, so that's all for this part. Thank you. Please try tutorial for chapter 2 for these parts, okay?